Hey everyone, welcome to section 5 of chapter 7, properties of logarithms. In this video I'm going to go over these 4 properties of logarithms. That's the product property, quotient property, power property, and change of base property. Okay, so take a log, any random log, or take 2 logs in the first 2 examples. And it can have any numbers plugged into it that you want, as long as the numbers for b, m, and n are positive real numbers and b is not 1. You can't have a log base of 1, okay? So if you're adding 2 logs together and they have the same base, it's like you're multiplying those outside numbers. So like if I had like log base 2 of 4 plus log base 2 of 8, that would multiply together 4 times 8, and I would get log base 2 of 32. That's what that's saying. So going the other way around, if you had a subtraction problem, you'd be dividing those numbers. So I'd have like 4 divided by 8 if it said minus in the middle, and that would be what, 1/2. You can do that as long as the base is the same, okay? So that's really important that the base is the same. Otherwise, you can't do that. All right, the next property is the power property, and that's if this outside term m has an exponent of its own, you would send that exponent to the back of the log, and it would turn into n log b of m, okay? And then the last thing is the change of base formula. So you use this when you have a log and you're trying to, I guess, simplify it or approximate it. And so you could take log base b of m and turn it into log m over log b, meaning these are both log 10s since there's no more base. You could also use ln, that's log with the natural base of e. The important thing is that that base is the same. So usually you just see a log. Again, that's log base 10 or an ln, okay? So to get into some examples here, we're going to go over product, quotient, and power property first, and we're going to expand logarithms using those properties. So here I have log base 2 of 49, and so I need to expand it using at least one of those 3 properties. So with log base 2 of 49, the first thing that jumps to mind is that 49 is 7 squared. So I'm going to use the power property to expand it, okay? Now, with 49, you could say, hey, 49 7 times 7. So you could do log base 2 of 7 plus log base 2 of 7. But since it's the same number, you should use that power property. If it's a different number, then we would be using the product property. But I'm going to use the power property, and the first thing I'm going to do is I'm going to write log base 2 of 7 squared. Okay, so using that power property, I'm going to take that 2, and I'm going to throw it to the front, so I get 2 times log base 2 of 7 for my final answer, okay? And that's all there is to say about part A. It can't expand farther than that. So let's just move on to the next example. So with log base 2 of 10x, 10's not really like a perfect square or cube or anything like that. So I'm not going to use that product property. The power property. But I can use the product property. How can I split this up? First of all, log base 2 of 10x, you can separate the 10 and the x. All right. So I can write it like this. Log base 2 of 10 plus log base 2 of x. And then if you really want to, you could even expand this. You could turn this into log base 2 of 5 plus log base 2 of 2, and then bring down that log base 2 of x. See, they all have the same log base 2, so it's really just like splitting it up into factors, okay? That's really what's going on here. It just looks strange because we're dealing with logs, but you've done this before with, like you're trying to factor problems and you're like, list all the factors of 15. Oh, 15 and 1, 5 and 3, So it's kind of in that ballpark. But this is the most expanded I can get with this, is breaking up that 10 into 5 and 2, and then, throwing that x on the side there. With C, we have a natural log, ln, of 5x to the 7th divided by y. So if you see division, you know it was originally a subtraction problem. So you have 5x to the 7th minus ln of y. So now I need to work with this ln 5x to the 7th. So the first thing you need to do is split it up. It's 5 times x to the 7th. So you have to write it as ln of 5 plus ln of x to the 7th. Okay, it's important that you split those up first, just like we did on the last example with the 10 and the x. And then I can just keep writing that ln y minus ln y. So now I have the 7, and I just take it to the back there. And so my final answer is going to be ln 5 plus 7 ln x minus ln y. And that is the final answer, because you can't expand it any more than that. So with D, we have log base 6 of 3x to the 4th. So that means the first thing I can do is go log base 6 of 3 plus log base 6 of x to the 4th. All right, again, because it's 3x to the 4th means 3 times x to the 4th. So you split those up, all right? And then now you have this exponent of x to the 4th. Bring that down, and so you're going to have log base 6 of 3 plus 4 times log base 6 of x. And then can you simplify this beyond that? No, you really can't. So this is going to be the final answer. So with E, we have ln of 5 divided by 12x. So first thing, let's split up that division. ln 5 minus ln of 12x. The division ones are probably easier to understand because you see that line physically dividing it, whereas with a multiplication problem, they're just smushed together, so you might forget to split them up because you might forget they're actually multiplying. Like this ln of 12x, that's multiplying ln of 12, and it's multiplying x, ln of x, or I guess technically adding ln 12 plus ln x, because you're multiplying 12 and x together. And then this ln 5 is just ln 5. So anytime you split up something on the bottom of a fraction, make sure you keep it together with parentheses, because I'm dividing 5 divided by 12x. So everything I split 12x up into needs to stay under the bottom of the fraction, so it needs to be with the negative, okay? So if it's in parentheses, then that negative will distribute to everything inside. So we'd be done at this point, except I can break down ln 12. What are your factors of 12? Your factors of 12 are 6 and 2 and 4 and 3. So it doesn't matter which one you use, you're going to get to the same answer regardless, but I'm going to use 4 and 3 because if I use 4, that gives me an opportunity to break that down, because 4 is 2 squared. So now we can use our product property, no, our power property, excuse me, and I can rewrite this as 2 ln 2, all right? If you used 6 and 2, you'd have to break the 6 down into 3 times 2, and so guess what? Your factors of 12 are 3 times 2 times 2, which means you have 2 ln 2s, which is what I wrote down right now. So that's what I mean by you'd get the same answer, okay? So let's bring everything else down, okay? Don't forget to write your parentheses, which is what I almost forgot to do on that one. And so I have ln 5 minus 2 ln 2 plus ln 3 plus ln x. So just distribute that negative, and you're going to get ln 5
minus 2 ln 2 minus ln 3 minus ln x. That would be the final expanded answer. You know you're done when you don't have any exponents or you can't break down the number any more than you can. I can't break down 5 anymore. The number's on the right. I can't break down 2 anymore. Can't break down 3 or x. So yeah, that's how I know I'm done. Okay? So let's move on. So in this one, we're going to go the other way now. Now we're going to condense. So condensing, I think, is probably easier because, first of all, if you have log 9, that's not going to condense into anything. So it's going to stay log 9 right now. But if you have a number in front, move that to the back as an exponent. So we're going to write it as log 2 to the third power minus log 3. Okay, so what's 2 to the third power? That's 8. All right, so now I have log 9 plus log 8 minus log 3. So because of the product and quotient properties, what I'm effectively doing now is I'm going to do 9 times 8 divided by 3. All right, so 9 times 8 is 72. So I have log 72 minus log 3. And 72 divided by 3 is 24. So I get log 24. And so if you type this in to the calculator, that 9 times 8 divided by 3 all at once, you'll get 24. I'm going to fix this log. It was bugging me. There. This one's not that good either, but okay. I think I'm getting off topic. But this problem's done. Log 24. Okay, so why don't you try this example by yourself? Okay, so give this video a pause and work it out. So on this one here, I brought the 5 forward, 2 to the 5th power made 32, brought the 7 forward to make x to the 7th, the 4 forward to make y to the 4th. These can't simplify beyond that, that's why they stayed x to the 7th and y to the 4th. And then you're just plussing. So if you're plussing, you multiply 32 times x to the 7th times y to the 4th. That can't simplify beyond that, so that's why the answer was just ln 32 x to the 7th y to the 4th. And that's all there is to say about that one. So these last few examples, we're going to talk about change of base. Remember, change of base is pretty simple. You just do, you just use the little base and then the number next to it, and you make a fraction. And you can write log of whatever base you want. Some people prefer to do log base whatever the original was. So like some people prefer to go, since this was a base 3, they'll go log base 3 of 8 over log base 3 of 3. And that worked just fine. In the notes, I said just do log of 10, so just log. So you could do log 8 over log 3. And that's what a lot of people prefer to do because you just write log, you don't have to worry about the base. The base is assumed 10. And if you don't want to have to worry about the base at all because the base is e, just do ln 8 over ln 3. That's another popular method. If you're watching other YouTube videos, you'll see a lot of people do either the log 10 or the log 8 over the natural log 8 over natural log 3. But all three of these are the same answer. If you typed it into the calculator, you're going to get the same exact answer on all of them. And that's pretty much because the base is the same on all of these with each fraction. Same on top, same on bottom, same on top, same on bottom. That's what I mean. So yeah, write whatever you want. Pick whatever answer you feel is the least confusing. I usually use the latter two. But yeah, let's do B. So B says 2 divided by log 3 of 9. So we can figure this out in our heads kind of right now, actually. This means 3 to some power equals 9. I know 3 to the second power is 9, so therefore this must equal 2. And 2 divided by 2 is 1. So if we do the change of base formula, I'm going to do log base 2 divided by log base, or just log, of 9 over log of 3. So that's log base 10 of 9 divided by log base 10 of 3. And so if you type this in, log base 9 over log base 3, you're going to get 2. All right? I can't show you the calculator at the same time I'm doing this video, but you get 2. Okay? So it says 2 divided by 2, and that's 1. But hey, if you could figure it out in your head like I showed you, more power to you, but this is math and you are required to show work, so you got to show me something like this. Okay? Let's do the last example. Here I have 4 to the power of x, and not 4 to the power of x, log base 4 of x, and log base x of 64. So looking at this without doing any work, I see a big X and a little x. That pretty much cancels each other out because you're multiplying. Sorry about my squeaky chair. And so basically it's going to get log base 4 of 64. And just like the last one, when I did 3 and 9, I know 3 to the second power is 9. I know 4 to the third power is 64. So this answer should be 4 when I'm doing it. So let's see here. We're going to do the change of base formula. So I'm going to go log base 10 of x over log base 10 of 4 times log base 10 of 64 over log base 10 of x. Okay? So if you have the same thing on top and bottom, meaning the same log and the same number, the most common mistake kids make is they just cancel out the word log, and then they end up doing 64 divided by 4, and they say the answer is 16. That's not what you're supposed to do here. You can cancel out logs if it's the exact same thing. I had log x on top and log x on bottom, so I could cancel them out. But I have log 64 on top and log 4 on bottom, so I would need to type into my calculator log 64 divided by log 4. And when you do that, you get 3 for your final answer, okay? And that's pretty much all there is to say about the change of base, all right? So thank you for watching. Until next time, goodbye.